Okay, we're going to start in this one about temperature. We're going to talk about a couple things real quick, and then we'll get to the fronts. So I hope you're not affronted by that or that offended. Anyway, whatever. Okay, but there we go. Let's talk about an inversion, first of all. In some places, for example, in Los Angeles, in this example they show, you have hot air moving in. In this case, we have hot air moving in from the desert over here. And as that hot air comes, it makes a layer of warm air up here. Now, normally during the day, as the ground heats up the air would start to rise. But when it hits this hotter air, which is even less dense than it is, it can't get through it. Okay? And since it can't do this, it is trapped, and we call this a temperature inversion. So we have hot air up here, cooler air down here, and this air can't, even though it's warmer than it was on the ground and started to rise, it can't escape out the top. All right, and so that's why Los Angeles has so much smog problems. A lot of times this air cannot escape. Now, here we don't have so much this hot air off the desert, but we do have high pressure air up here. Either it's high pressure up here, or it could be warmer air up here. And we talk about the cap, okay, and that means it will not. We have warm air, cool air that's warming up, rising, and normally it would billow up into big storm clouds and stuff and make thunderclouds. But as long as there's high pressure air up here, or it could be also high temperature air, it forms a cap, and it will not let the clouds expand upward, and so and turn into those nimbocumulus clouds that make the big thunderstorms. And so even though we have moisture in place, we have heat in place, and we have airs trying to rise to make those clouds, we say that no, it shuts, the cap will shut down all the rain chances for the day. All right. Another way that weather can be affected, in this case also kind of geography in this case, is the presence of mountains. Okay, generally say we have warm moist air here. As it reaches a mountain or some other type of obstacle that causes it to rise, it has to rise. Well, this is kind of the same kind of rising that if it heated air rises, okay, but the same thing's going to happen. As it rises, it gets cooler, so it begins to condense and make clouds, okay, and may to the point of precipitating. Okay, by the time it gets over, as it lowers, it actually warms up. So if there's any moisture left, it is very often reabsorbed back into the air, because now it can hold more, because we know that warmer air can hold more precipitation. And so now, if anything, a lot of the water that was in these clouds evaporates back into the air, and so there's basically no clouds over here, no moisture left, because they've lost all the moisture as they cool down going up the mountain, and as they warm up going down, it re-evaporates back into the air. So if anything, there's less moisture, and so we say you have a rain shadow or deserty area. And this is on the west coast. Once again, moisture comes in off the coast, goes over the first range of mountains, comes down on the other side, and you have this rain shadow. And deserts, Death Valley, and some of that kind of stuff would be the extreme example of that. Now, this also occurs in the Rocky Mountains. If you go to Colorado and the Rockies, or even New Mexico, the west sides tend to be more moist and whatever. The east side tends to be drier. Okay, and if you look at eastern Colorado, the extreme example, of extremely short grass, very barren type landscape, almost desert-like, because by the time all the mountains have gone through all the Rocky Mountain ranges, by the time it gets over to eastern Colorado over here, there's no moisture left, and it's almost deserty type conditions. All right, now we said that kind of like with boundaries, we're talking about the Earth's plates crushing. All the excitement happens on the boundaries where they hit each other. Well, in this case, in weather, we talk about air masses, and the excitement really happens once the air mass becomes in place. It's just either warm or cold or whatever. But the excitement happens is when the fronts hit each other. So the boundary between air masses are called fronts. Okay, we have a warm air mass, cold air masses, but when they hit each other, that is considered a front, and that's where all the changes happen in the weather. Sometimes very quickly and violently, sometimes not so much, but basically that's what causes our changes in weather, is when these different fronts hit each other. All right, so first kind of front we're going to talk about is a cold front. Okay, this one here has a cold front. If you look on the weather map, the symbol for this will be a line like this with a bunch of triangles on it, and they would all be shaded in, but I'm not going to be able to do that with my little pen. So, and it's like this, points in the direction it's going, and so if this would be a cold front that's moving in this direction. And so a cold front means basically you've got a cold mass of air back here. Okay, very cold, very dense. Cold air tends to be dense, so it's going to be very dense, very heavy, so it's going to be hugging the ground. And as it comes along, it's going to push the warm air up in front of it, and it's going to push it up in the air. And kind of like we talked about some of the other cases, when you take warm air and moist air and you push it up rapidly, it's going to cool off. Water's going to condense, it's going to form clouds, and eventually possibly build into cumulonimbus clouds, which are the thunderheads, which have your big storms. Now, since this shuts it up very quickly, very fast, it's very blunt, squared off here at the end, so it's going to push that up real fast, and when it pushes it up, it happens very quickly. And so usually thunderstorms, these are kind of thunderstormy type clouds, possibly tornadoes. And so usually if you're up here, it's warm, then all of a sudden, boom, these clouds move in, you have a violent storm, more violent weather, and then quickly pass. Sometimes maybe 20, 30 minutes, and it'll be clear skies again, but it'll be colder air, so it's followed by cool, fair weather with not much clouds and stuff like that after that. But the actual storms are very violent, very sudden, and they usually don't take very long. So they change very quickly when we get a cool front coming in. The next type we're going to talk about is a warm front. Now notice the name for what type of front is moving into the other area. So in this case we have warm air moving in. Now warming air tends to just kind of slide up over the cold air. So you got cold air over here, you've got warm air over here, and the warm air just kind of slides up over the cool air. So it's a much more gentle pushing up the air. Still the air is rising, so it begins to condense more and more water droplets, and eventually we have usually these tend to be your more sustained, gentler rain, just kind of a steady downpour. And then and notice that since this warm air gives you forewarning, you see a lot of clouds. Cirrus ice crystals up the very high ones first, and later you see some stratus clouds, and then eventually you get the drizzle coming. And so it's more of a gentle storm. Obviously afterward you would tend to have warmer, moist air after, fairly humid. If you have sticky warm weather after it, that was probably a warm front that has moved through. Okay, now a warm front symbol would be the little half circles this time instead of the pointy triangles of the cold. Think of the teeth of a cold storm. All right, warm storm is going to be more like a banner. Okay, we're happy because it's waving banners. Okay, whatever. All right, there we go. So that would be our warm front. Okay. Now, sometimes a warm front and a cool front will hit, but instead of one of them moving on top of the other one, they will just stall out. Okay, and so let's say this warm front hits this, and it just stalls. Okay, and instead of pushing on over and pushing the cold air out of the way, it just stops. This would be called a stationary front. A stationary because it's not going anywhere. Okay, so stationary front means it's just sitting in one place. Okay, and so the stationary front is not going to change the weather very much. It's going to stay same. Usually this rain, wherever it is, where it meets here and the warm weather meets the cold air here, there's going to be some type of rain, and that rain's just going to sit there. So you have steady rain for several days. The temperature depends on, if it changes, depends on if the warm front pushes this direction or the cool air pushes back the other direction. Okay, so eventually one will push the other one out of the way, and that will change your temperature. The symbol for that, since you have two fronts going different directions, we may have pointy things on one side for the cold front trying to go one direction, and you have the rounded things trying to go the opposite direction. So we've got a cold and warm front on both sides and going in different directions, and that's basically what that would be. All right, now the last type of front that we have, it's going to be called an occluded front. Alright, the last type we have is an occluded front. Occluded front is basically where a squeeze job, where you have warm air in the middle and you have cold air in front that the warm air is moving up, kind of was a warm front. Now you have a cold front behind it, and basically the cold front squeezes into the cold air above it, and all the warm air gets shoved up. Okay, this cold front probably has some thunderstorms. This one over here might have gentle drizzle. When it gets shoved up, you have some real heavy rain right there because all these warm air is being shoved up from both sides, the cold air here and the cold air here. So it's getting shoved up, and as it gets pushed farther and farther up, then eventually it becomes very light rain, and of course you would have just cooler temperatures because this. So you would end up less violent weather than the thunderstorm, maybe a little more than you would have from the rainstorm, but eventually you end up with just some light rain. as it pushes the warm air up, and you end up with just cooler temperatures down the front because you have the two sets of colder air. Now the symbol for occluded front, just because we don't have anything else left, I guess, is a warm front symbol, cold front symbol, warm front symbol, cold front symbol, warm front. Okay, because it involves both of those. But in this case, the warm fronts are being squeezed up. The warm air is being squeezed up by two bodies of cool air. And that's it for our fronts.